just like in Cisco, it's possible to configure NTP or network time protocol, and it's such a good practice. Probably just a good idea to quickly look at the config here. So let me just add that. So underneath our system hierarchy, you can now see we have some NTP config. We've got the IP address of that NTP server that we'd like to be syncing our time from, and also a boot server. So if you're not familiar with NTP, it might be news to you that the NTP RFCs specify that NTP shouldn't just randomly believe, or randomly is a bit harsh, shouldn't just blindly believe, any NTP server's served time. In fact, if the current system's date and time is off by more than 1,000 seconds from the time presented by the NTP server that I'm highlighting here, then Junos isn't going to believe that time. He's going to stick with the currently configured system time. Now, if we boot the box again, we'll check with the boot server. So the boot server in my example is an identical IP address. It doesn't have to be a different IP address. So at boot time, whatever date and time we're given, regardless of how many seconds off it is from the current system's time, we'll believe that. I don't in my lab have an actual NTP server to point to, but in operational mode we can, after committing this, query our NTP servers. So if we show NTP associations, we'd get some output that tells us what's going on with that NTP server. So here we have a simple SNMP configuration. Best practice, obviously, that we're monitoring our devices, and this is a fairly simple, easy way to get it up and running with version 2C of SNMP. You can see that we've set some description for our router, its location, some contact admin, our SNMP community, public, effectively the password. But more than that, we're also being a little bit particular about who is allowed to actually present SNMP polls to the device. So we're only going to be responding to clients within the configured subnet. And then we'd also like, not just to react to polls requests for SNMP information. We also want to fire off SNMP traps when events occur. So we have a trap group named My Traps, and underneath there I've configured the category of events that I would like to trigger SNMP traps. Where am I going to send them? I'm going to fire them off UDP to some target, some IP address out there that is my network management system collecting those traps, so it can merrily page somebody in the middle of the night for me. One of the nice features I'd just like to cover quickly is the ability to automatically archive configurations off the box. So here underneath the system hierarchy, we have a look at the archival configuration. We can see under System Archival that we've set it up that configurations should be transferred at commit time or on commit time, but where should they be sent? They're being sent to an archival site. Now we might have chosen FTP, but as a best practice, it's probably better to go with SCP, secure copy across an SSH. What are we going to SSH into? Some username at some IP address, some local path on that server, and then we better give it a password as well that it's going to use to log into that device. And now when I type commit, this is going to attempt to fire off an archival of the config over to our remote server. So it'll obviously be local in the system as a rollback, but we'll now also have a copy remote. If for whatever reason that SCP server goes down, that won't stop us committing. Okay, we're going to see log file messages telling us we couldn't make the archival, but we're not going to see it actually prevent us from changing the system configuration.